Do you guys have any idea how Moderna determined that the efficacy rate, just of the vaccine is 94%? How did they do that? Have you been watching videos on YouTube, CNN, social media, and how they arrived, just at this number? Does anyone have an idea? Why how did they figure out the 94%? Let me tell you how. In order to test, just whether the vaccine is effective or not, they do an experiment. And everybody is doing an experiment. Johnson & Johnson is still doing an experiment. Pfizer will continue to do the same experiment, and Moderna is continuing, just their research with more and more people, just in the samples. They bring two groups. One is called the control group, and one is called the treatment group. The control group, guys, will receive no vaccine. They get nothing. And the treatment group will get the vaccine. So the one that will get nothing, probably they'll give him a shot. They don't tell him it is the vaccine, but it's just water. There's sugar, just a solution, just in there. They call it a placebo effect, just there's nothing. And then they monitor, just the two groups. So one who got the treatment and one who did not get the treatment. Let's say we had 10,000 volunteers. 5,000 got nothing and 5,000 got the actual shot. And let's say out of the first 5,000, 300 got COVID-19, and out of the other 5,000, another 300 got the COVID-19. Then what conclusion can you guys make about the vaccine? Is it effective or not effective? Same number of people from both groups got COVID. What does this mean? And
Not
it's
effective.
not effective. Now, if you had 5,000 and 5,000 in both groups, I'm just making this up. There were more than 5,000. They say, I think there were 40,000, but I'm just making 5,000 for simplicity. If 400 from the group who got the placebo got infected with the virus, and 0 from the group who got the treatment, who got the shot, got infected, what would you say about the vaccine?
It was effective.
100% effective, because nobody got COVID. So it's 100% effective. Now, here's how they figure out, the 95%. They were from the group who did not get the treatment, there were a larger number, just of people who got infected with the virus. But with the group who got the shot, only 4 or 5% of them got infected. And that's why have they figured out, just the 95%, because they subtracted, just from 100%. So this is how they figured this out. It was a very, very small percentage comparing to the other percentage, just from the placebo group. And that's how they came out, just with this, what they call it, just efficacy rate. I have some videos, guys. If some of you are interested, just in the real actual data, what happened, I can share it with you. So actually in real life, guys, to test the effectiveness of something, you just always, especially when you want to do an experiment, when you want to do an experiment, you always have to bring two groups. Let's say a pharmaceutical company wants to test, just of a medication is good in lowering, just cholesterol. This is what they bring. They will bring, just two groups. They take their cholesterol level, just before the treatment. One group will be asked to take the medication for, let's say, 3 or 4 or 5 months. And another group will get placebo placebo pills. They wouldn't know that it's not medicine. They'll just give them nothing. and they monitor both groups. If they notice that the cholesterol, just is getting a lot lower, just with the group who got treatment, they make a conclusion that the medicine is effective. If they notice, it's very much the same, just with both groups, then they can make a conclusion that the medicine, just is not effective, and probably they have to do another study. So it will always involve two groups. If, let's say, I want to make a claim that my students, my female students, perform better than my male students in my class, in order for me to process the claim, I need to collect data from the female students, and I need to collect data from the male students and compare the two data sets. If the information that I get will support, just my claim, I say my claim is valid. If the information that I got does not support my claim, then I have to say that I cannot support that claim. Probably my data, cannot be validated, just to support my claim. So just have an understanding. Usually, guys, chapter 8 is the key, because most hypothesis testings that are done, just are done using two samples. Okay, and we're just going to begin, just learning about how to compare two samples, and to do tests, just between two means. But before I get into this, guys, I'm going to ask you this question. If you have two numbers, A and B, and I want to compare the numbers, what sign would you put? I'm not going to tell you what A and B are. If you comparing, what are the possibilities that A is what? A could be what? Less, more, etc. What would one possibility that you can think of? If you want to put simples here, what would you put? Give me all the possible simples.
Equal to.
Equal to B, that's one possibility.
Greater than.
What did you say?
Greater than.
Okay, that's another possibility.
Less than.
That's a third possibility. So you see, it's the same signs that we use in chapter 7. There is another possibility, one more. There's three more, actually, guys. You gave me three.
Greater than or equal to.
Okay.
Then less than or equal to.
And there's the last one.
And not equal to.
Exactly. These two guys gonna be together. And these two are gonna be together. And these two are gonna be together. So it's the same thing as in chapter 7. When we compare two groups. In chapter 7, we did only one group. But in chapter 8, we're going to do two groups, but this is not going to change the statement of the null and the alternative hypothesis, guys. You will notice that HO will always have one of those signs. Nothing changes at all. I still get the same signs. This is the only algebra that I need you to know. But you just need to know this, guys. If someone writes A greater than B, it's the same thing, guys, as writing A minus B is greater than 0. And let me tell you why. If A is greater than B, if you subtract B from both sides, you get A minus B on this side. And if you get B minus B on the other side, it's greater than 0. These two statements are exactly the same. And if A equals to B, guys, if you subtract B from both sides, it's still exactly the same statements, A minus B equal to 0. These two statements are exactly the same. And if A is less than B, if you subtract B from both sides, you get A minus B less than 0. These two statements are still exactly the same. So it doesn't change anything. But we're mainly are interested, just to know that the null hypothesis will have one of those signs, and the alternative hypothesis will have the alternative sign. These two come together, these two signs come together, and those two signs come together. All right. Independent samples. We say that two samples are independent if the sample selected from one population is not related to the sample selected from the second population. When you select two different samples from two different populations that has nothing to do with each other, we say that they are independent. And let me give you an illustration of an independent sample. This is an illustration of independent samples. They have no relationship. You see they're separate, sample 1 and sample 2. But in the second example, I claim that they are dependent. Can you guys tell me why I claim that these two samples are dependent here?
They're identical.
You see the relationships? So this number from sample 1 is related to a member from sample 2. So they are related, dependent. That could be here the fathers, and here that could be the sons and daughters. And that's why when you see those arrows going from one sample to another, it's just hinting you that the samples are dependent, I'm sorry. So two samples are called dependent if each member of one sample corresponds to a member in the other sample. When there is a relationship, we say that the samples are dependent. When there is no relationship, we say that the samples are independent. Let me give you examples, guys, and tell me if you think that the samples are dependent or independent. I don't think that this should confuse what you know about chapter 7. And the opposite, I think it will strengthen your knowledge of chapter 7, because I know some students are worried that they get mixed up, but this is two samples have nothing to do with chapter 7. Classify the pair of samples as independent or dependent. Weight of 65 college students before their freshman year begins. Weights of the same 65 college students after their freshman year. What do you guys think?
Independent. Independent.
It's the same group that you have their weight before they begin their freshman year and then take their weight after they begin their freshman year. Wouldn't that make them dependent because they're the same group in both sets? They are dependent here. If it is the same group of people that you're referring to, they must be dependent. Let's look at this one. Now look at this. I'll give you a second. Scores of 38 adult males, a score of 50 adult females. They have nothing to do with each other. They're totally two different groups. 38 adult males and 50 adult females. And I hope that with this example, you can see that these have nothing to do with each other and they are independent. Let me just get a few more examples from the book. To enforce independent and dependent sets. I think after this example, you should be able to tell me, give me a better answer when it comes to dependent or independent sets. There you go. Number 5. Sample 1, the maximum bench press weights of 53 football players The maximum, then sample 2, the maximum bench press weights for the same 53 football players after completing a weightlifting program. Let's see.
Dependent.
Yep. Exactly. Dependent. It's the same group. What about 6? That should be easy. IQ score of 60 females, IQ score of 60 males.
Independent.
Independent. Does everyone agree with this? Because on the next test, guys, probably a couple of questions will just be asking you to identify whether the sets are dependent or independent. Takes 5 seconds if you know what you're doing. What about 7? Average speed of 23 power boats using an old hull design. Average speed of 14 power boats using a new hull design.
Independent.
Independent. And guys, one thing that you can say independent right away, if it's not the same size, it's impossible to be dependent. Because when it is dependent, it's the same group before and after. So it has to be the same group. Look, 23, 14, that's it. But I know he tried to trick you in number 6. He gave you the same number. But remember, here it says females, and over there it says males. 2 different groups. So these are independent in 7. What about 8? The commute time of 10 workers when they use their own vehicles, the commute time of the same 10 workers. And you see when I stress on it, I think you have a hint. When they use public transportation, we're talking about the same 10 workers. So what would that make it, guys? Dependent. Yes, I agree. It is dependent. So that should be easy, you know, just to, so the hint, guys, for dependent sets when it says the same number of people. So like if I pick 15 students in my class, I took their heart rate, you know, before they took the test. And then the same 15 students, I take their heart rate while taking the test. That's dependent because I'm doing an experiment on the same students before and after. When you see 2 sets before action and after action, then you guys can conclude that the 2 sets are dependent. Okay? So now you have a very good idea of what dependent and independent sets are. Now, let's continue. Here's how we're going to be testing the hypothesis. The null hypothesis is a statistical hypothesis that usually states that there is no difference between the parameters, and we'll be using those signs. The alternative hypothesis, as you know, guys, it's always true when the null hypothesis is false, and it will use one of those signs. When we compare 2 population means, guys, in chapter 7, you were asked to compare the population mean against a number. Here, it's going to be a lot easier. That's why what I meant, it's going to be easier. He's going to give you 2 sets, guys, set 1 and set 2. And he's going to be asking you to compare, you know, just the means. In chapter 7, we call the population mean is mu, but since we have 2 population in chapter 8, we need to distinguish the 2 population means. So we give him simples, mu1 and mu2. mu1 could be the population of all female students. mu2 could be the population of all male students. And he's asking you probably to compare that. The average score on the test for females is higher than the average score on the test for females. So probably you want to check if mu1 is greater than mu2. So there will always be 2 means. The first mean refers to the first population, and the second mean will refers to the second population. Remember in chapter 7, guys, he will give you X bar and he will give you sigma. Here you're going to have an X bar 1 and X bar 2 and sigma 1, sigma 2. If he'll give you a sample size N, in chapter 8, you're going to have N1 and N2. If he gives you an S, it's going to have S1 and S2. So it'll always come, just in pairs, information about the first set and information about the second set. Significance level alpha will be alpha. That doesn't change. So it will remain alpha. So this is the difference between chapter 7 and 8. When you state the null in the alternative hypothesis, guys, here's why it's going to become a lot simpler. You always come back here and choose one of the three. In any problem, testing 2 means you either choose this one or choose the second one or choose the third one. Now you tell me, Mr. Bazzi, how do I make, it's 1, 2, or 3. If he's asking you to test that the first mean is different from the second mean, then it's going to be this. If the question asks you to test that the first mean is bigger than the second mean, then it will be that. If the question is asking you to test that the first mean is less than the second mean, it will be this one. So it's in the context of the question. Whatever the question is, you just can decide which one it's going to be, but it can't be any but one of those guys always. So that's what makes it a little bit simpler now. Regardless of which hypothesis you use, you always have to assume that the null hypothesis is true unless proven otherwise. Remember, the defendant is not guilty until proven otherwise, and that's how we do hypothesis testing. We assume that the null hypothesis is good until we have enough evidence against it. If we don't have enough evidence against it, we don't reject the null hypothesis. Okay, first of all, we're going to learn in section 8.1 2 sample z-tests to test the difference between two population means when sigma 1 and sigma 2 is known. In section 7.2, guys, you learned how to test the mean when sigma is known. Now you're going to learn how to test two means when sigma 1 and sigma 2 are known. Instead of one standard deviation, two population standard deviations are known. And these are the conditions of the test. 4 conditions are necessary to perform a z-test for the difference between two means. And the good news, the calculator can perform the test, guys. The population standard deviations are known. Sigma 1, sigma 2 known. The samples are randomly selected. He has to give you random samples. The samples are independent. He has to say that the samples are independent. And the population are normally distributed or the sample size is more than 30. So if he says the population are normally distributed, we're good. But if he doesn't, he has to give us a sample that is at least 30, like 31, 32, 37, as long as it is more than 30. How do we perform the test? That's a good review for today's test. You state HO and HA. You calculate the standardized test statistic Z because we're performing a Z test. You calculate the p-value and you make a decision to reject or fail to reject the null hypothesis. Interpret the decision in the context of the original claim, and I'm ready, guys, to show you how to work out an example. Let's do this together. So we're going to begin with this example. If you're going to grab a piece of paper or have your calculator handy and do your calculations with me, that will be great. And we'll be using technology throughout this chapter, guys. So it's all going to be based on the use of the calculator. So let me just begin with this one. A credit card watch group claims that there is a difference in the mean credit card debts of households in California and Illinois. So we have 2 states, guys, California and Illinois, and they're stating that there is a difference in the mean credit card debts of households. I'm going to pause here, guys, and show you the 3 statements. Which one would you choose? Number 1, number 2, or number 3? They claim that there is a difference in the credit card debts between the households of California and Illinois.
The first one?
First one,
First
equal or
one.
not equal.
Because it has equal or not equal. Why the first one? Because it has a difference. That's why I'm choosing the first one. That's it. So I'll state, I think I have a space on the other page, but I'm just going to state him here. Remember, mu1, it's California because he uses 1 here. And Illinois is 2 because he uses 2. Where is the claim, guys? In HO or HA?
HA.
Yep. Very good. As I told you, you don't need to dig hard, to find the null and the alternative. Just pick them from the list above, always. The results of a random survey. Remember, one of the conditions of the test that you have this to have random samples. So condition number 2 is met. The results of a random survey of 250 households. So N1 is 250. Look, guys. From each state are shown at the left, well, it should be at the bottom here. The 2 samples are independent. Remember, one of the conditions of the test, guys, for the samples to be independence. Here you go, right here, you can see him, number 3. Assume that sigma 1 is 1045 and sigma 2 is 1350. This is the first condition, guys. The population standard deviation are known. They gave them to us, sigma 1 and sigma 2. And then condition number 4 is met. He says the population are normally distributed or the sample size is at least 30. Well, look at the sample size, guys. It's 250, which is more than 30. So all 4 conditions of the test are met. So yes, they are met here. And let's run the test. Step number 1. We stated the null and the alternative hypothesis. And step number 2, guys, let's get your calculator ready. Since sigma 1 and sigma 2 is z-test, but because I have 2 samples, it's called 2 sample z-test. Let me show it to you. You're gonna like this test. It's very easy to be performed. All right, watch, guys. Click on stat. Go to tests. And I want one student to tell me what the test is. Which one is it gonna be? It's very close on the top of the screen.
2 sample z-test.
You got it. It is, just think of chapter 7. It's a z-test. I know one student just sent me a text and was worried that they'll get confused, just when we do 8 with the, when taking the test. When you guys take the test, don't look at anything that has 2 samples in it because this is only for chapter 8. So in chapter 7, we do a z-test. Here, we're gonna do a 2 sample z-test. And watch. He wants sigma 1, he wants sigma 2, he wants x1 bar, he wants n1, he wants x2 bar, he wants n2, and you already have all this information, guys. That's right here. I got sigma 1, 1045, and sigma 2, 1350. So let me put it there. X1 bar, guys, right here. 4777 and N1 is 250. Let me put it there. X2 bar 4866 and 250. And N2 is 250. Okay, next step. Choose the sign from the alternative hypothesis. Which one do I choose from the alternative hypothesis? What's the sign in the alternative hypothesis, guys? Is not equal, so you just choose not equal. Here you go. And then don't care about the color. You can do a calculate or a draw. If you want to do a calculate.
It asks on a calculator pooled, yes or no.
Oh, you
that
got the wrong test. You got 2 sample t-test. It should be z-test.
Oh, I clicked on accident. Oh,
See? Just be careful. It's a z-test. When he gives you And again, for the test today, guys, if he gives you sigma, it's Z. If he gives you S, sample standard deviation, it's T. So now we're gonna just do a draw and watch, guys. It's a 2 sample, you get the p-value, look, it's large. Z is negative 0.82. So we ran 2 sample Z test. Z is negative 0.82. And let me write the p-value, guys, and we'll be done. We'll go back to chapter 7, same conclusion, 0.4098. And alpha, what did he say? Alpha 5%. So you guys agree with me that this is bigger than alpha. So what's the step number 4? Do I reject HO or fail to reject HO?
You reject it.
Fail
Bigger
to.
than alpha.
Oh, bigger than alpha? So
Fail
reject.
to reject it. Make sure to write this down on a note, guys. P-value less than alpha, you reject HO. P-value bigger than alpha, you fail to reject HO. Okay. And this is an excellent review for the test today now. So fail to reject HO. How do I start? There, what?
There is not
Not
evidence
enough evidence at the 0.05 level of significance. The claim is in HA, so what word do I say?
Support.
Support. We're not saying we're supporting, we're saying we're not supporting. Not enough evidence to support the claim that there is a difference in credit card. I'm just copying and pasting the language of the claim. Debts between California and Illinois. That concludes the problem, guys. That's it. That's how you perform what we call a 2-sample Z test. We use a Z test when sigma 1 and sigma 2 are known. And you guys, if you're looking at my screen, you see here it says assume that sigma 1 and sigma 2 are known. That means it's just going to be a 2-sample Z test. So I know you might be tired of listening, so let me give you and this one. And I like your help with this one. A travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. He labeled Texas as number 1 and he labels Virginia as number 2, as you can see. So can you guys help me state the signs? I'm just gonna put him here. mu2, mu1, mu2. The cost of vacationing in Texas is less than the average daily cost in Virginia. So what sign goes in the alternative hypothesis?
Less than.
Yeah, it's obvious, guys. It says less than. And you can be sure that this is a greater than or equal to, and that's the claim. And as I stated earlier, guys, it has to be one of the 3. And it turned out to be this one this time because he says Texas is less than Virginia. Now, what he labeled Texas as 1, so I have to go with that because look at the table. It says number 1 is Texas. The table below shows the results of a random survey of vacationers in each state. The 2 samples are independent. First of all, the samples are random because he says they are random. The samples are independent because he says they are independent. The population standard deviation are given because he gives them to us in the question. And then and he says the population are normally distributed. then that's the 4 conditions are met. If you are asked to verify the conditions, they have been verified. At alpha equals 0.01, is there enough evidence to support the claim? And he's asking you if you can support the claim, guys, because the claim happened to be in the alternative hypothesis. So,
I have a question.
yeah.
And you said that the 4 conditions are met, but I thought the sample size have to be at least 30 because they're less than 30.
Look, the population are normally distributed or the sample size is at least 30.
Okay, thank you.
So if the first one is met, you're good. It doesn't matter what the sample size is. If the second one, the first one is not giving, then definitely the sample size has to be more than 30. If you go back to the previous question, you notice he gave us a sample size 250, but he didn't mention anything about whether the population was bell-shaped. We didn't care because the sample size was more than 30. All right, guys, 2 sample z-test, as simple as that. And all I need to just plug in the numbers in there. So I'm gonna get the calculator ready. Stat, tests, number 3. So for section 8.1, it's number 3, guys. All right, sigma 1. Let's see what he says about sigma 1. $19, and sigma 2 for Virginia is $24. So $19, $24. X1 bar is $234. So let's see if it costs less in Texas than Virginia. Let's see if we can approve of this. N1 is 25. X2 bar is 240. N2 is 20, guys. And then we need the third one, if you agree with me. Make sure, guys, when you take the test today, when you select, the sign from the alternative hypothesis, make sure to press enter to select it. And then you want a draw? I can do a draw for you, or a calculator, doesn't matter. Let's do a draw. You see area to the left, it's a huge p-value, so we're gonna fail to reject the null hypothesis. So z is negative 0.91, and the p-value, guys, is 0.1808. Let me copy it, write it down again. 1808. And you guys agree with me that this is bigger than alpha, which is 0.01. And so what's the decision? Let's just a review for the test today.
Fail or reject.
Yeah, fail to reject HO. That is correct. If the p-value is more than alpha, you fail to reject HO, guys. If the p-value is less than alpha, you reject HO. You hear me? I've been repeating this this is probably the 3rd week I've been repeating this. And I will be saying it the whole time. So fail to reject HO, and here's how we start. Look, my technique. There is. When you have a fail, you start with there is not enough evidence at the 0.01. You have to copy this. Level of significance. The claim is in HA, so to what? My math lab will ask you to choose support or reject.
Support.
Support. The claim that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. So I'm not gonna write it down, just to support the claim. Okay, and that concludes section 8.1, guys. Perform a 2-sample z-test for the difference between 2 means when you compare 2 population means, mu1 and mu2, with independent samples when sigma 1 and sigma 2 are known. Any guess, guys? What do you think the section 8.2 is going to be about?
The standard deviations are not known.
Exactly, it's the same thing, but instead of 2 sample z-test, we will be using 2 sample t-test. That's just like 7.2 and 7.3, guys. 7.2 you use z-test, 7.3 you use t-test. It's just going to be very much, but instead of 1 group, you will have 2 groups. So I'm stopping the video for this one. I'm recording a new one.